So we have two problems here for varying loads. For our first problem, we have a American iron steel institute for 3140 and oil winch temperature of 1000 Fahrenheit. So our SU is 153 KSI, SY is 134 KSI, SN is 0.5. SU is 0.5 multiplied by our 153 KSI, we have a 76.5 KSI, and our SN is 52 KSI. Our double acting or F max, we have a formula of F equals PA. We need to distribute. We have a 125 multiplied by pi over 4, 20 squared, and our F max is 39,270 pounds or 39.27 kips. And our F minimum is 39.27 kips, also watt negative. And our SA, we have a formula of 4 multiplied by F over pi d squared. We need to distribute the values. We have 4 multiplied by 39.27 over pi d squared was 50 over d squared, and 1 over 1.75 equals 0 plus 50 over 2 over d squared, and we have a diameter of 1.2972 inches. And our Soderberg line, we have a formula of 1 over n equals Sm over Sy plus Sa over Sn. And our SA is formula of 4F over pi d squared. For our number 2 problem, our American Iron Steel Institute, we have a 2,330 and our water range temperature is 1000 Fahrenheit. Our SU is 105 PSI, SY is 85 PSI. Our SN, we have a 0.5, SU multiplied by SU, 0.5 multiplied by 105 of SU, we have a 52.5 PSI, and our SM is 0. And we have a size factor of 0.85 and factor for action is 0.80. For our SA formula, 4F over pi d squared, and we have a 4 multiplied by 5 over pi d squared and equals to 20 over pi d squared. This is our equation 1, and for our next formula, we have a 1 over n equals Sn, which is 0 plus Sa over Sn. And for our machine surface, we have a surface factor of 0.85. So Sn equals to 0.85, Su equals to 0.80 multiplied by our size factor, which is 0.85, and surface factor 0.85. Then multiply it by our Sn, which is 52.5 equals 30.325 PSI. And for our SA, we have a formula of 20 over pi d squared. Distribute our Sn, which is 30.345 and over 1.4. So we have a diameter of the machine surface of 0.542 inches. For our mirror polished surface, we have a surface factor of 1, Sn is 0.5, Su is 0.80 multiplied by our size factor, which is 0.85, our surface factor, which is 1, then multiplied by our Sn, which is 52.5, and we have a 35.7 PSI. And for our SA, we have a 20 over pi d squared. Distribute our 35.7 PSI of mirror surface over 1.4, we have a 0.5 inches. And for our forged surface, we have a 0.40, Sn is 0.5, so 0.80 Sn multiplied by our size factor 0.85 times 0.40 of forged surface and 52.5 our Sn, we have a 40.58 PSI. And for our SA, we need to distribute our Sn, which is 40.58 PSI over 1.4, and we have a 0.79 inches of forged surface. So for our number 3 varying loads, we have a solution for American Iron Steel Institute. We have a C1020 as ruled, and SU for 65 PSI, SY is 48 PSI. So for it, our SN, we have 0.5 we have 32.5 psi. And our surface factor as forge, we have 0.55. So for our A, we have a SM of 0 and SA equals to MC over I. So our I, we have a formula of I equals T B cube over 12, and just distribute, and we will have a 1.8293 T over 4. And for our C, we have B over 2, and just distribute, we have a 2.8 T over 2, which is we have a 1.4 T. And we have a formula of M equals FL, so we just need to distribute. We have a 900 pound multiplied by 14 inches. We have a M equals to 12,600 pound or 12.6 inches cubes. And for SA, we have a 12.6 multiplied by 1.40 over 1.8293 T over 4 was 9.643 over T cube. And for our SN, we have a 0.85 multiplied by 0.55 and 32.5, which is 15.20 cubes. And for our formula, we have a 1 over n equals Sm plus Sa equals Sn, which is our Sm is 0 and 1 over n equals n. So we just need to manipulate, and we have a Sa equals Sn over n of formula. And we just need to distribute its values, and we have a 9.643 over T cube equals 15.20 over 2. This our T is 1.08 inches, and our B was 2.8 T, and we just need to distribute our T, which is 1.8, and we will have a B of 3.0 inches. And for our B, we have solution of M equals FC, and we need to distribute our 900 pounds multiplied by 4 inches, and we have a M of 13.6 inch cubes. And for our SA, we have 3.6 multiplied by 1.40 over 18,203 T4 equals 2.755 over T cube. And we have a T of 0.713 inches. And for our B, we just need to distribute our value of T equals 0.713 multiplied by 2.8, and we will have a B of 2 inches.